Hello everyone, my name is Utkarshi Chauhan and in the previous video we has discussed about this topic data preparation phase to model the data and now in this video we are going to explore the model evaluation and in this we learn these two topics how to perform model evaluation using Python and then accounting for unequal error cost using Python. So first we understand with the help of PPT and then we understand with the help of code. So let's get started. So first we understand what is model evaluation. So first before deploying any machine learning model, you must assess how well it performs. Model evaluation answer question like, is the model accurate? Does it generalize well to new data? And is it good at predicting the right outcomes like spam emails and disease or sales trends? And is it good at predicting the right outcomes like spam emails, disease or sales trends? And then in real life, we use evaluation to check if our models are ready for production. For example, let's say you are building a filter and you need to evaluate how well it's classify emails as spam or not spam. This is classification and we will use that as our example here in the code with the help of code. And accuracy matrices key performance indicators first precision recall and F1 square precision measure the proportion of correctly predicted positive instances among all predicted positive instances. And second, recall measures the proportion of correctly predicted positive instances among all actual positive instances. And F1 square represent the harmonic mean of precision and recall, providing a balanced measure of accuracy. And then confusing matrix involving classification errors. First column is true positive, second one is true negative, and third one is false negative, false positive, and fourth one is false negative. And then cross validation ensure robust evaluation, k-fold cross validation, stratified validation, and leave one out cross validation. And regression metrics are measuring model fit, R squared, mean squared error, and root mean squared error. R squared measures the proportion of variance in the dependent variable that is explained by the independent variables, and mean squared error calculates the average of the square differences between the predictive and actual values. And then root mean squared error, the square root of the mean squared error, providing a measure of error in the same units as the dependent variable. And handling unequal error costs, adjusting thresholds like first one is analyze the cost associated with each type of error in your specific problem and then adjust the model decision threshold by weighing the consequences of false positive and false negative, and then use cost sensitive learning techniques to incorporate the error cost directly into the model training. And visualizing model performance, ROC curves. ROC curves is plots the true positive rate against the false positive rate for different decision thresholds. And AUC stands for area under the ROC curve, representing the overall performance of the module across all decision threshold. And then interpretation, a higher AOC indicates better module performance with a value of 1 representing a perfect model. And what is the conclusion of that? Apply model evaluation to enhance of your projects. First, understand your data and then choose the appropriate matrices and then visualize performance, then iterate and improve. Now we will understand with the help of code. So first, how to perform model evaluation using Python. So first, from sklearn matrices import classification report comma matrices matrix row AUC source generates a detailed classification performance and includes precision, recall, F1 square, and support for each class. And confusion matrix creates a confusion matrix showing the number of true positive, false positive, true negative, and false negative. And AUC score computes the area under the receiver operating characteristic curve, AUC, ROC, and a performance matrix for binary classification problems. And then from sklearn dataset import load iris provides it provides access to the iris dataset and a classic dataset for classification task with three flower species. And from sklearn module selection import train split uh, splits the data into training and testing sets for model evaluation. And from sklearn assemble import random forest classifier implements the random forest algorithm, a robust assemble learning method that combines multiple decision tree for classification. And then we load the data set. Data is equals to load iris, loads the iris data set into a variable data containing feature data, and targets the table data dot target. And then we train a model. Model is equals to random forest classifier random state 42. Then this feature sets for training and testing. And then we loads the iris data into a variable data containing feature data and data dot target. And then this feature sets for training and testing, and these target labels for training and testing. And test size is equals to 0.3, allocate 30% of the data for testing and 70% of the training. And random state 42 ensure reproducibility by using a fixed random like that. And then we train the model is equals to random forest classifier random state is equals to 42. This initialize random forest classifier with a fixed random state for reproducibility. And model dot fit x train comma y train the random forest model on the training data x train and the corresponding label y train making prediction. And and then making prediction y pred is equals to model dot predict x text, evaluating the model with matrices. And then with the help of this we run the Python code on the Google Colab. So this is the output of the above code. So this is the confusion metric has rows corresponding to actual classes and columns corresponding to predicted classes, and each element represent the count of sample for a specific combination of actual and predictive classes. So first we break down it. So row 1 class 0 is a 19 instances of classes were correctly predicted as class 0, and no instances of class 0 were misclassified as class 1 or class 2. And row 2 class 1, 30 instances of class 1 were correctly predicted as class 1. No instances of class 1 were misclassified as class 0 or class 2. And then row 3 class 2, 13 instances of class 2 were correctly predicted as class 2, and no instances of class 2 were misclassified as class 0 or class 1. What is the summary of this output? All predictions are perfect and no misclassification in that. Now move to the second topic called accounting for unequal error cost using Python. So first, predict probabilities instance of classes. Y props is equals to model dot predict proba x text dot 1 sets the threshold for classifying an instance as positive class 1 to 30% and 30% and compare probability with the threshold above threshold class 1 and below threshold 0 and converts boolean value true false to integer 1 divided by 0 and then we print the confusion matrix. It computes the confusion matrix to show true positive, true, true positive, false positive, true negative, and false negative, and prints how prediction differ under the new threshold. And then print classification report adjust threshold. It generate matrices like precision, recall, F1 square, and support for each classes, and evaluate performance after adjusting the threshold. Now we will understand the output of this code. So in the first row, class 0, 19 instances of class 0 were correctly predicted as class 0, true positive, and 0 instances of classes 0 were misclassified as class 1 or class 2, false negative 0, and in the second row, class 1, 13 instances of class 1 were correctly predicted as class 1, true positive, and 0 instances of classes 1 were misclassified, false negative 0. And then in the second row, class 2, 0 instances of classes 2 were correctly predicted, true positive 0, and 13 instances of classes of 2 were misclassified as class 0, false negative is equals to 13. And what's the summary of this output? Classes 0 and classes 1 have good performance with all instances classified correctly. And class 2 performed poorly as all instances were classified as class 0. So, and in the next video, we will discuss about the naive based classification. And thank you for watching my video.